Welcome to our video on solar energy at the Spruce Mountain School System. This is our greenhouse, and it's solar powered. And it's solar powered in a couple different ways. The first way it's solar powered is it uses passive solar energy. Passive solar energy is when energy passes through the glass and simply heats up the inside of the greenhouse. Also, if you look up above me, there's a small black photovoltaic solar panel. Photovoltaic solar panels make electricity directly from sunlight. So right here on the outside, you can see it uses passive solar and photovoltaic solar. So now we're inside the greenhouse, and as you can see, this gets a lot of passive solar energy. The sun is over here, it's the morning, the sun is rising in the east, the sun is going to move through the sky, and we are in the northern hemisphere, so we are north of the equator, which means as the sun comes up in the east, it goes through the southern sky for us, and it's going to track like this, and then it's going to set over there in the western sky. So our greenhouse has been specially built to point south. South is behind me. And that way the sunlight is coming into the greenhouse all day long. That infrared radiation from the sun is able to pass through these glass panels. And it's short wavelength infrared radiation, which means it has a lot of energy, and it can get in here and it can warm everything up here. It can warm up the plants, it can warm up the ground, and it warms all the stuff up. And then all of these things, they then give off or kind of reflect that infrared radiation, but that infrared radiation that's reflected has a longer wavelength. And because of that, when that radiation tries to escape, it hits the glass, and most of it bounces off and comes back in. And this is called the greenhouse effect. The greenhouse effect works because light from the sun comes in, it heats stuff up, and then the re-emitted radiation of heat can't escape, and it gets trapped inside the greenhouse. And that's how a greenhouse works. It uses passive solar radiation. So now we're looking at the north end of the greenhouse. We've switched around the camera and myself, so now I'm standing towards the north. And the first thing you're going to notice is that behind me, we have this silver insulation. So what happens is sunlight travels in and it comes through that glass. We call, again, this is passive solar heating. That sunlight comes in. When it hits this silver material, it gets reflected downward. This silver has a curved shape, almost like a parabolic satellite dish. And it focuses the light down in here to this water tank. And we're in a little bit of disrepair this year because it was a COVID year and we really didn't grow anything out here this winter. Some of our insulating panels have fallen down. We need to get out here with a ladder and fix some of this stuff up. But you can see that this silver stuff behind me is going to reflect the light into the water. This water tank holds over 1,000 gallons of water when it's filled. It's actually partially buried in the soil, and it actually goes down a foot below ground level. It holds 1,000 gallons of water. So what happens in the wintertime is on a bright, sunny winter's day, the greenhouse, the heat hits it, and it traps the heat inside using that passive solar. The water acts like a thermal mass. The water temperature heats up during the day. And then at night, when the air starts to cool off, the water is now warmer than the air is. So the water gives that heat back to the air, and that allows the air to stay a little bit warmer in here, and it allows us to grow certain crops in the winter. Things like kale and leeks can grow out here throughout the winter because of this thermal mass. You also notice we spray painted this thing nice and dark black. Black is a great color because it absorbs solar radiation and then it re-emits it when the air temperature gets colder at night. Black does not attract the sunlight. It's not like sunlight gets pulled in. That's not true. What black does is when sunlight does hit it, it absorbs that solar radiation and holds on to it. So our passive solar system is just simply all of the windows are trapping the heat from the sun in the greenhouse, and the thermal mass helps to trap even more of that, and then the thermal mass gives that heat back off at night when it's cold and when the heat's needed. So by building this greenhouse and having it face south, putting a reflector on the north to reflect that heat into the water, and having a thermal mass, all allow us to use this greenhouse throughout the year without having any kind of external heat source. It's just solar heating. So there are really three ways we use solar energy. The first one we've already talked about, passive solar. You have windows, the sunlight comes in, and the greenhouse effect traps the light. The second way that we can use solar energy is by heating hot water. And we saw that with a hot water tank in here in the greenhouse. That thermal mass collects and heats up with water and releases it at night. The third method of solar energy is called photovoltaic. Photo means light. Voltaic means voltage or electricity. So photovoltaic means making electricity with sunlight. And if you look up here, that little solar panel that I showed you from the outside, it's mounted there and it's connected to this wire. And the wire runs down here along the greenhouse, and it's disconnected right now. Again, this has been a very bad year for us with COVID, but it's connected to this box and this fan right here. See, the fan has some wires on it. And when the sun is shining on that panel, it will turn this fan on, and this fan will blow air up through the top of this piece of plywood. This piece of plywood sits on top of this box right here, and this box is actually made to sit on top of these three pipes. Come right over here so you can see the pipes. So there's three pipes right there. And those pipes run down underground under this planting bed. Go ahead and walk around the planting bed. And they're under the bottom of it, and they're actually going to come up over here. Two of the three pipes come up over here. So those two underground pipes, what happens is, during the winter when the sun comes out, it turns on that fan, and it pulls air down through these pipes under the planting bed, and then the air comes up on the other side. And by pulling air under the planting beds, it keeps the planting beds from freezing. There's also a third pipe that's right over here in this little planting bed. This pipe, the hot air goes down under the planting bed, and then the pipe comes out and goes underground and comes up over here to the fan as well. So two pipes go this way and one pipe goes that way. And in these three pipes, they take that warm air and they keep the heat in the ground. And the whole thing that does this is our photovoltaic solar panel. That solar panel up there makes electricity out of the sunlight. That electricity flows through this wire, which runs the fan. You've probably seen photovoltaic panels in other places. For example, if you have a solar-powered calculator, the little tiny black solar panel is a photovoltaic panel. It doesn't need much electricity to run a calculator, so that little panel makes just enough electricity so you can do calculations. We're going to go look at another photovoltaic panel that we have here at the school that's much larger. So we're outside the high school right now, and this yellowish building right here, this building is the high school's heating oil tank. Every year trucks come and they fill this building, this giant steel tank, with oil. And we use that heating oil to heat our school. And if you turn over here, you'll also notice that we have natural gas propane tanks. Propane and heating oil are both fossil fuels, and burning fossil fuels contributes to climate change. When we burn fossil fuels, they release carbon dioxide into the air, which traps heat from the sun in our atmosphere. Well, this is a little ironic, but if you look up on top of this, the roof of our heating oil tank, you will see we have a set of photovoltaic solar panels. And those photovoltaic solar panels are collecting light from the sun. You'll also notice that they're pointing southward because the sun is going to go through the southern sky in the northern hemisphere. And they're collecting sunlight and they're making electricity and they're wired to the high school, and they're producing renewable, clean energy for the high school. So it's just kind of funny that they put the solar panels on top of the oil tank, because really solar energy is out to replace oil. But for heating right now we're using a lot of oil and a lot of natural gas, and maybe someday we can get to free solar electricity and energy for our energy needs. So this is the computer dashboard. It's available on a website online that tells us how our photovoltaic panel out there on the oil tank of the school, how it's working. And this dashboard, it says PV system overview. PV means photovoltaic, which means making light from electricity. Electricity from light. And the PV system at Spruce Mountain High School, right now, it's making 601 watts of electricity. You can think of a light bulb, a normal 60-watt incandescent light bulb has 60 watts. So if we're making about 600 watts, that means we could be powering 10 light bulbs right now with the electricity that's being made by our solar panel. And this is the system status, and it's got a green check mark that tells us that everything's working okay out there on the system. It's telling us how much energy it made today, how much money it's made us today, how much carbon dioxide it's avoided, because instead of burning fossil fuels, we're making energy with sunlight. And if we don't have to burn fossil fuels, we're not making carbon dioxide anymore. So this little number right here tells us how much. Now, so far today, and it's only 9 o'clock in the morning, we've avoided an ounce of carbon dioxide being made. Also remember, solar panels don't work at night. This is only going to produce electricity when the sun is out. We have a whole bunch of other information, our location, what's the current weather out there. This is all here. But another thing I can do is I can scroll down to this graph, and I'm going to click the total tab. This shows the total amount of electricity that's been made every year. This solar panel was installed in 2014, and you can see right about here, this is in what we call kilowatt hours. So right now, when we look at how it's done over the years, it's typically made between 2,000 and 2,500 kilowatt hours per year. And you can see it fluctuates a little bit depending on how sunny the year was. 2016 was a particularly sunny year, so it made a little bit more electricity. 2015 was a cloudy year, so it made a little less electricity. And you can see 2021, well, it's only May, so we have a long way to go to see where it's going to be for the year. This will keep adding as we go on and on and on, and hopefully by the end of the year, this blue band is going to be up here somewhere. But this shows us how much is made, and then it says average yield expectations is this gray bar, so it's performing just a little bit under expectation. And part of that is they had to mount it directly to the roof, and the angle that panel is mounted at isn't perfect because it's the angle of the roof. And that actually costs us a little bit of yield. If it was pointed a little bit more towards the sun, we'd probably get a little bit more yield out of our system. But you can see that by using this electronic dashboard, we can look at the total. We can look at how much electricity has been made so far this year. And again, the gray is the average expectation, and the blue is what we made. We're only on May 21st, so we're not done with this month yet. But you can see March was a really sunny March. We made a little bit more than normal. But April was a little bit cloudier, so we made a little bit less than normal. And this will continue to fill in the blue bars as we go through the year. We can also look at what it has done for month by month, day by day. So this shows each day. And you'll notice that some days we get a lot of electricity when it's really sunny out, but other days we get less electricity because it's cloudy out. Like, looks like May 5th, was a particularly cloudy day. And it looks like May 21st was May 6th was a particularly sunny day. So May 5th we had clouds, May 6th we had sunshine. So you can track all of this data about how well the solar panel is working. And again, photovoltaic or PV means it makes electricity directly from sunlight.